Okay, so I'm going to go through question 5 from paper A from PHY 101 2013 to 2014, which is a relativity question. It's one of the optional questions, and it's all about an electron and accelerator. So I tell you in the question that an electron with negligible initial velocity enters a cyclic accelerator. Each time the electron goes around in one cycle, it gains an energy delta E. So part A asks you to write an expression for the total energy E as a function of the number of cycles, delta E, and the mass of the electron, the velocity of light. So you start with negligible velocity, in other words it's got no kinetic energy. So the total energy contains a contribution from its energy when it's at rest, which is just its rest energy, mc squared. And then it also contains another contribution from after n cycles it's gained a kinetic energy of n delta E. So this is the rest energy, and this is the kinetic energy. And that formula for the total energy is enough to get you 3 marks from part A. So the moral of this story is, do not look at the number of marks as a barometer of how much work you have to do. I want you to actually have the confidence to write down an answer, even if it looks to you as if you didn't have to do enough work to deserve it. What you've done actually is display the fact that you've got enough confidence to know that your answer is right, and that is worthy of some marks too. So part B is, I want to know what's the value of n, how many cycles you've gone through when you reach V is 0.99c, or beta equals 0.99. Well, we know that gamma, the relativistic factor between total energy and rest energy, is just 1 over the square root of 1 minus beta squared. And if you substitute in beta of 0.99, you get gamma of 7. You may also remember from the course that gamma of 7, or beta of 0.99, is the lower limit in velocity, or gamma, of the highly relativistic regime. It's also the upper limit, of course, of the mildly relativistic regime. So you might actually just remember that gamma is 7 for beta of 0.99, but if you don't, you can just substitute into this formula, and as long as you don't forget to square the beta, you'll get the correct gamma. Okay, so once we know that gamma is 7, we can write the total energy as gamma times the rest energy mc squared, and that's equal to the sum of the rest energy and the kinetic energy, which in this case are written as nc squared and n delta E. We can then take the right hand side and factor out mc squared, and cancel mec squareds, and we get that gamma as a function of n is just 1 plus n delta E upon mec squared. Now we know that for part B, this result's going to be useful by the way, so we know for part B that gamma is 7, which means that n delta E upon mec squared is going to equal 6, or n is the rest energy mec squared over the energy increment per cycle delta E, which equals 0.51 MeV, that's the rest energy of the electron, which I think is on the formula sheet, divided by the energy increment per cycle of 50 keV, and taking the ratio, being careful with the units, because this is 1,000 times as much as that, you get n equals 62. And that's the answer to part B. In part C, what I wanted was a general expression for beta as a function of n. Now we already have an expression for gamma as a function of n, and if you look at that expression down here, gamma is 1 plus n delta E over mc squared, and then look at the question, I tell you that you can replace n delta E over mc squared with r, so that gamma equals 1 plus r. Now we know, again, that gamma is 1 over the square root of 1 minus beta squared. If you invert this formula and express beta in terms of gamma, you get, and I'm sure you've done this several times in the homeworks, beta equals the square root of 1 minus 1 upon gamma squared. And if you substitute the expression for gamma in terms of r into this formula, you get beta equals the square root of 1 minus 1 over 1 plus r all squared. And that's a perfectly acceptable answer for part C, in fact. You could also write, as some of you do, substituting back in the expression for r, beta equals the square root of 1 minus 1 over 1 plus n delta E upon m c squared all squared. That's a perfectly acceptable answer too. Now in part D, we are told to take a limit. We're told to take the limit that n is very much greater than mec squared upon delta E. Or m delta E is much bigger than mec squared. So if you remember, m delta E is the kinetic energy, mec squared is the rest energy. So this limit is the limit where the kinetic energy dominates over the rest energy. The electron's been in the accelerator for sufficient cycles that its total energy is dominated by the energy due to its motion in a lab frame. So if you look at this formula, the m delta E in the denominator of the second term, the square root, is going to be much bigger than mc squared. But notice that that term, which is much bigger than 1, has 1 added to it. So in the limit where m delta E is much bigger than mc squared, we can drop the 1. And so you get beta is approximately the square root of 1 minus 1 over m delta E upon mec squared all squared, which is the same thing as 1 minus me squared c to the 4th over n squared delta E squared to the 1/2 power. We're almost there. All we have to do now is recognise that in this form, mc squared over n delta E is the rest energy over the kinetic energy, which is small, and then the whole thing squared. So this term here, which is 1 minus, the quantity in the minus sign here, is a small parameter. Now you might remember from the binomial expansion from maths, I hope you remember this, if you have 1 plus a small quantity, so epsilon is much less than 1 in this case, all to the pth power, then to first order in epsilon you can write this as 1 plus p times epsilon. That's one of the most important approximations in physics, so please try and remember it. We apply that here, the epsilon is minus m squared c to the 4th over n squared delta E squared, and the p, the power, is 1/2. So we can write that beta is approximately 1 minus, the minus sign is carried over because the small parameter includes the minus sign, don't forget that, m squared c to the 4th over n squared delta E squared, and then the half comes down and multiplies the small quantity, so you get a 2 down here. So beta is approximately 1 minus m squared c to the 4th over 2n squared delta E squared, and that's what you were asked for in the question. So that's the end of part D and the end of question 5.